So, good morning, friends. It's April 22nd. Yesterday was Easter. It's also my mother's birthday. We had a good time. We went over to a friend's. She got to chat with her granddaughter by means of Skype. Wonderful. Thank you very much. Also, today, Quaker Nation goes up. That's just a quick little essay that's about if you're in our Quaker U, right, and you're doing data science, what's it like to manage a database of 8 billion human beings? Now, 8 billion might sound like a lot, but in terms of data, it isn't, and it's not really big data. It easily fits on your laptop. You might be thinking, well, what fields am I trying to track? Like, is this real data? And the answer is no, it's not real data. And it's up to you what fields you want to track. That's what we're helping you think about, right? It's about data structures, SQL. Do you want to track the citizenship of everybody? You could start with that. Have a table of nations. I don't know what, virtual nations, fake nations, real nations. It's up to you. And then 8 billion synthetic people that, you have your random identity creators, your algorithms for filling this database with random but believable data. That's a whole job in itself to write that kind of stuff, right? Okay, so that was not my main topic. My main topic is looking at very basic Python and just getting clear on a couple topics. One is they both have to do with creating things and dealing with things that don't exist that you thought might exist. Okay, so that's pretty abstract. But in terms of something concrete, we have what's called the assignment operator in Python. Like if I go capital A equals and just say the number 4, that creates a binding between a name and something in memory, the number 4. And actually the numbers are just canned. They're stored up to a certain number. They're just already there as objects. And no matter how many names I create for the number 4, it's still going to be the immutable number 4 in memory, that one object. Different though, if I have really big numbers, like I create C equals, and I just put in some random number that big, and then if I were to copy that, cut and paste it, and say D equals that a second time, it's not like there's some one place in memory where that number actually is pre-stored. It is true though in the case of 4, because 4 is such a common low number that we can afford to store some of these things permanently. So if I ask, are A and B the same object in memory? Is that the same 4 that they're both pointing to? The answer is true. Yes, they are. But if I ask the same question about C and D, not the case, all right? Next thing, if I repoint A to something else now, I'm going to point it to a dictionary, which we use the braces, and dog is going to be my key, and cat will be my value. That's a one-item dictionary, right? I can get a list of A's items this easily, and it's just one item. Now the question is, if I go in looking for a key that doesn't exist, and I just get this list, I don't have time to parse it with my eyes, I've got a busy job, so I'm going to go fishing, and I'm going to ask for like a zebra inside of this A thing, and I have no idea if it's there. And so chances are it isn't, let's say, and it raises a key error. This is like blowing a whistle, like a foul. Now, if you know your Python, you know one way around this problem, you could call it a way around, is you'll take the key and the dictionary as two parameters. You're going to pass these as arguments, and then you're going to try to look up and return F. You're going to try to return D sub key, you could call it, looking up key in D, and if it's not there, that same key error we're just witnessed will be raised internally to this function. In that case, we'll return a default value, such as ostrich. I know that's very contrived. Why on earth ostrich? It's okay. It's jungle theme today. So let's try to pull up our dictionary from the same dictionary we just tried. Let's use zebra as our key and pass in A, the dictionary, and it comes back with ostrich, so that works. However, another function, much simpler, could do this in one line, and actually you can, don't have to write a function at all. You can just write code to do this, return D sub key, but we don't use square brackets, we use the .get method, and either the key is there, in which case we return the corresponding value, or we return some default, in this case ostrich. So that's another function that's going to operate from the user's point of view in exactly the same way, and it's easier to understand. So we could say that this code, the d.get solution, is semantically the same as that code, right? So that's something to keep in mind. This is the .get method of the dict type, and all dict type objects, of course, will have access to that shared method, which is in one place in object. It's in the dictionary type, which is, stored pre-canned Python, your dict. All right, I'll talk to you in the near future, and have a great day.